So I'd like to offer you a very warm welcome to the Innovation Hub, which is hosted by Agri-TechE with the support of the Royal Norfolk Agricultural Association. A short while ago, I was in conversation with two Agri-TechE member businesses. I spoke to Roger Sylvester Bradley from ADAS and to David Clark from NIAB. Here we are in conversation together, talking about some of the innovations that they are presenting at the Innovation Hub this year. Roger, please could you introduce yourself and tell me why you're at the Innovation Hub today?
Well, yes, I'm Roger Sylvester Bradley from ADAS. I'm head of crop performance for ADAS, and I should have retired 10 years ago, but actually we've been doing some of the most exciting research that I've ever done in the last 10 years, and we call this action research. And basically action research in any industry is where the industry itself is doing the research at the coalface. So for farming, that's in the fields, by the farmers, with the farmers' equipment, with the farmers' inputs and with the farmers' measurements. So we started a yield enhancement network in 2012, and what I'm talking about today is the second generation of the yield enhancement network, which is particularly focusing on crop nutrition.
That's really helpful. Thank you very much indeed. So we'll come back to that in a bit. David, if I could ask you to introduce yourself and tell us what you do.
So I'm David Clark. I'm a soils and farming systems research technician at NIAB, working in the soils and farming systems team alongside Elizabeth Stockdale and Nathan Morris. I'm based at Morley in Norfolk, and I've been to the Innovation Hub at the Norfolk Show the last 3 years actually. But one thing we're keen to demonstrate this year at the Norfolk Show is one of the trials we manage in East Anglia in Saxmundham in Suffolk, which is a long-term nutrition trial. It started in 1899, so we're over 120 years of trial data. Originally set up to look at what the relatively modern techniques of the time of mineral fertiliser, so this is similar to what we buy in our garden centres, bagged fertiliser, compared to more traditional methods of applying farmyard manure. However, that's sort of come full circle now, because we're sort of looking at how the benefits of applying farmyard manure in terms of soil structure and organic matter may have the other benefits than just the bagged fertiliser. But we are also updating some of the treatments to more modern, relevant pea management techniques to tackle the problems with pea management in the 21st century. So the Saxmundham experiment and the work at Morley looking at organic matter and organic amendments is supported by the Morley Agricultural Foundation, which is a charity that supports agricultural research that NIAB and other organisations use.
And that's really helpful. Thank you very much. So Roger, could you please explain what the Yield Enhancement Network is and specifically what the second generation will be focusing on?
Yes, so the Yield Enhancement Network is pretty much what it says on the tin. So it's a network of farmers and many other organisations that are interested in enhancing the productivity of arable land, and particularly of cereal crops. We started with cereal crops, and since then we've introduced yens for oilseed crops and for pulse crops and even for grass crops. So we're trying to improve the productivity in a joint way between scientists, farmers, suppliers, advisors. So all these groups of people are collected together in this network. It includes about, last year we had about 300 farms involved in the Yield Enhancement Network for cereals and for oilseeds. And one of the key things that we've come to recognise is that a lot of the farmers who are producing high yields are using organic manures, and because we've been analysing the soil, as is conventional on farms, but we've also been analysing the crop's leaves to see how the nutrients are being taken up. But we've also, and this is a global first, in fact, that is measuring the nutrients in the grain that the farmers are harvesting. So we're now, for the last 4 years, been getting a really good picture of the nutritional status of the crops that are these high-yielding crops that farmers are harvesting. And we've come to recognize that there are a lot of nutritional issues that farmers are facing. And so in our second generation of the N, we've tried to simplify things so that any farmer can engage any field in this new network, so that they can assess, just by analyzing their grain, the nutrient status of their crops, and to see where the strengths and the weaknesses are in their nutritional management.
That's really helpful. Thank you very much indeed, Roger. I want to come back in a few minutes to the grain analysis and specifically how that ties in with the second generation. But David, if I can ask you, Roger made reference to crop nutrients. Can you explain perhaps the work that you've been doing, and in particular the findings that you've had in relation to crop nutrients in relation to plant fertilizer?
So at Saxmundham, bringing the 120-year trial using modern technologies, one thing we do is monitor how the different treatments, so the treatments we have are things like annual applications of farmyard manure, and that's the only P or K fertilizer that receives. We have plots there that have no P or K fertilizer, or then increments of both. And we've been monitoring yield for 120 years, not personally myself, but other trials. But what we haven't done is looked at actually how much, we've got very detailed soil results, and we know that the soils of some treatments are very, very low indices soils. We've got some that are indices 1, which means they're, based on conventional understanding, they're probably not quite meeting crop demand. Indices 2 is where farmers want to be on most soils, and that should provide enough phosphate to the plant. So we have all of them broad spectrum of soils at Saxmundham, and one technology we're using now is when we combine and harvest the crops, we're sending the grain off for analysis and actually seeing how much of that is making its way into the grain. And that's come off the back of the work that Roger and ADAS have done. And there's good understanding of how much there should be for something that's meeting its phosphate demands. But that also allows us then to see, well, okay, on these really low indices soils, which may be potentially more likely something we want to be managing in the future, how can we allow the plant to have sufficient amounts of phosphate? So we're looking at different techniques, such as one of the techniques we're looking at is by using compost, which is relatively low in nutrient value, but very high in organic matter, and therefore improving the structure of the soil. Can we maintain lower indices? So can we maintain soils that have less of the nutrient, which have benefits from other reasons, both environmentally, but then also inputs cheaper for the farmer? Can we maintain lower P indices soils, but through improved structure, allow the crop to utilize the nutrients that are there better? So that's one of the treatments. And then a second treatment is actually how can we use the nutrients that we apply in more innovative ways? So there's not relatively new technology, but applying foliar phosphate. So this is applying the fertilizer to a growing crop onto the leaf, and then it is taken up through the leaf, through the epidermals and the stomata, and into the crop that way. Again, this has benefits from potentially reduce the amount of phosphate in the soil that then may make its way out of the soil into places we don't want it, such as watercourse.
So I'm going to come on to the innovation side of things now. So Roger, you mentioned that you had come up with a global first in terms of being the first business in the world to be measuring nutrients in harvested grain, so in harvested wheat and barley. Why is it so important to do that? Why has nobody done it before? And how farmers can use that approach to get involved in the next generation yield enhancement network?
We actually still are in a position where many farmers don't measure what they harvest. It's a really weird situation where we've got a primary production industry that manages its crops field by field, so that all the expenditure is decided on a field by field basis. But very often the farmer is so concerned to harvest the grain quickly and get all the grain into the barn or into the store, that he or she actually doesn't weigh it, doesn't measure it. So we don't actually know how successful our management is in an accurate way. We know roughly, so that the whole farm has produced a full barn or a half full barn, and I'm afraid this year it looks like it's going to be half full barns, but we don't know field by field. So the importance that the innovation in the yield enhancement network, before we started focusing in on nutrition, was just to get yields from fields that farmers were all taking, that they all trusted. So we joke about pub yields. So farmers will boast about their yields in the pub, but those are useless in a commercial business, and they're useless in a scientific study. So we need yields that people will trust. So the yen started by organizing a competition, and a competition has to have people engaged that trust everybody else's measurements. So when we start focusing on the nutrients, the same thing in our view applies. So far, nowhere in the world, as far as we can see, anybody is measuring the grain that they take off the field. Yes, people like David are measuring it from their small plot trials, but the farmers are not measuring it. But when we actually look at what the variation in the concentration of the nutrients in the grain that the farmers are harvesting, and this is from over 900 fields over the last 4 years, we've seen twofold variation in each of the nutrients. So the phosphorus may be 4 kilograms per ton, or it may be 9 kilograms per ton. And yet what farmers have been assuming when they've been doing their sums of how much phosphorus have I been removing from my field, they've been assuming 8 kilograms per ton so far, which is a number that came from experiments in the 1970s when nobody was really aware of all the environmental consequences. We've now had a look and said that that's too high. So the average that we're now advocating in the fertilizer recommendations is 6.5 kilograms per ton. But actually we know that 6.5 is a gross average of everything varying between 4 and 9. So it's very important for the farmer to get the offtake estimate right so that he or she knows how much fertilizer to apply to replace it. So that's the first reason that why grain analysis is really useful. The second, and to me much more valuable reason for analyzing grain, is that actually the same analysis that analyzes the grain for phosphorus also analyzes for all the other essential nutrients. And there are about 12 essential nutrients. We can argue about 1 or 2 of them, but 12 essential nutrients. We can get results for each of those nutrients on the same sample with the same analysis. So we're introducing a way for people to go on our website, register their 6 fields that they want to analyze. They pay a little bit more than just for the analysis so that we can then analyze all the data together. So it's a network where we're sharing the data, and everybody's data can be shared with everybody else's data. So we can do benchmarking, and we can compare each level of each nutrient from each field with all the other fields. And that is a sort of revolutionary way of farmers actually doing their own research, so that they're actually measuring what they're doing with their nutrition across the board.
Thank you very much, Roger. That's really interesting, actually, with all the upheaval that you talk about in terms of off-takes. I mean, I did once upon a time know all those off-takes by heart, so that when I was talking to a customer, I could just throw those figures out. But if you're coming along changing them, so it's a whole new set of off-take figures to learn, which I'm pleased I no longer have to do that. David, I'd be really interested in understanding some of the findings from a crop nutrition perspective from your long-term Sax-Mundham trials.
So on the back of what Roger's just said about knowing how much phosphate and other nutrients we're taking off, what we're more focused on is actually how we can get that quantity that we know we need to get back into the soil or into the plant, how we best do that. And that's what we're working on at Sax-Mundham. So with the finite supply of rock phosphate, it's not just understanding how much we need to get back into the soil or into the following crop, it's how we best do that. So one piece of work from AHCB, the ADAS and NIAB were both involved, and found that actually from across a number of sites across the country, that actually on soils that, particularly in cereal crops, autumn drilled cereal crops, with soils that had lower indices than eventually thought was acceptable, but where we had very good soil structure or good management, actually yields weren't severely impacted by having lower phosphate soils. And one thing I will say is that the current phosphate, so triple superphosphate is what they call the phosphate that is mostly applied to soils, is actually quite ineffective at getting phosphate into the plant. I think it's only about 4% on average of that is then uptaken by this year's crop. The rest goes into the soil and is then utilised by following crops. But again, that's reasonably inefficient way of doing it. So we're looking at ways that maybe we might improve that efficiency. One of them is by allowing the roots to get the phosphate that is in the soil better by improving structure. Another one is looking at a foliar application. So we are applying a foliar phosphate. This is just a liquid fertilizer that's sprayed onto the crop as it's growing, and the phosphate stays on the leaf and then absorbed through the leaf and into the plant that way. So we're looking at that. We've applied that we're starting with 4 times across the season. So we're trying to time it when farmers would spray other things such as fungicides, so therefore it could go in a tank mix. So this will keep the costs down, so they're not having to do 4 extra runs on the field to spray with phosphate through the year. And that's the first year of doing that. So we'll be looking, and that's explained in the videos on the virtual innovation hub. But the results will be the first time this year, comparing that to plots that have received 120 years of farmyard manure, so very, very good soil structure, but also higher phosphate levels, and those that have received 120 years of bagged fertilizers. So it's a unique opportunity to look at how these modern techniques might stack up against techniques that have proven to work over the last century or so.
Thank you, David. That's so really interesting. It's very good to hear that. You've talked in particular about how your innovative approaches, the technology, the grain sampling, for instance, Roger, can lead to improvements in yield. Obviously, the focus of YEN is on yield, but perhaps just explain how technology, how innovation can be used to help tackle the environmental problems associated with phosphate.
I mean, the sorts of things that David is describing is exactly what we have anticipated will happen as a result of introducing grain analysis. So nobody's done grain analysis before. They start doing grain analysis, they look at that grain analysis, and they can see that one particular nutrient on their field, or maybe all their fields, is low compared with everybody else's. And then they have to think, why is that? What have I got to do to make that come right? And very often, they will have used soil analysis. Soil analysis doesn't tell you about all the nutrients, it just tells you about P, K, and Mg. Generally, you can do it for boron and 1 or 2 other nutrients, but generally, you only do it for P, K, and Mg. So that's phosphorus, potassium, and magnesium. And if the soil phosphorus is satisfactory and your grain level is low, you're obviously getting something wrong with the uptake system. So what David is talking about, which is really untested, and so it's really important that people try and test these things on sites like Saxmundham, where you've got a contrast in soil phosphorus from low to, I imagine, reasonably high.
Index 3, yeah.
Where we have that possibility of doing testing, then we can test ideas like foliar nutrition, which will really help the environment, because you'll just be fertilizing the leaf and not the soil. So, and the environmental risk is from the soil. So if we can actually get much better efficiency from foliar uptake, then we can allow the soil levels to go down without it being detrimental to productivity and food supplies. Because if our yields all go down, we'll have to find new farmland to feed the world. So, and that will be an absolute disaster as far as carbon is concerned. What we want is to maintain productivity, but without these subsidiary effects on the environment in our in our very productive farmland. With this grain analysis, we're opening a whole realm of investigation that can happen farm by farm as farmers discover that they've got problems with particular nutrients.
That's brilliant, Roger. Thank you very much indeed. David, if I can ask you, there's a lot of focus at the moment on soil health. You've mentioned soil structure as well in terms of improving the efficiency of TSP. What are you finding in relation to soil health in general terms, and what sort of messages are there to help people understand the importance of soil health?
So first thing I do is I can draw on is actually the Sax-Mundham experiment, where we have the farmyard manure plots compared to the plots that have always received phosphate and potassium fertilizer. In terms of their nutrient content, they are pretty much the same. They are sufficient to meet crop demand. However, in some years, last year being one of them, we saw a much higher yield in the plots receiving farmyard manure. And we believe that is because of 100 years of farmyard manure application. So in that, you've got the straw, you've got various bits of other organic carbon that's going back into the soil, and it's only increased soil organic matter. So we measure soil organic matter in a percentage. It's only increased the amount of soil organic matter by about 0.5%. So it's about 4.2% in where we've got farmyard manure, so compared to about 3.6, 3.7 where we haven't been applying it. So it's not very much, but what you do see is if you dig a hole, you visibly see what 0.5% in organic matter looks like. The soil is much more better structured, it crumbs better, and it's darker. And this autumn, I've got a good photo from this autumn where it was ploughed in very difficult conditions after a very, very wet autumn, and you can see the farmyard manure plots because you haven't got the smearing of the plough going through the plot. So that it is visual difference. And what we see is in seasons where everything's not quite perfect for crop development, last year, actually, we believe, looking at some of the grain analysis and measures we took during the year, is actually when we applied nitrogen to the crop, we didn't get any rain for about 20 days, I believe it was. So therefore the crop, the plots that had better soil health, they both allowed to utilize that nitrogen that did make it into the soil better, but they also allowed to utilize the nutrients and nitrogen in the soil that was already there. And we saw about a 1 ton response in the FYM plots compared to the plots that had just received bagged fertilizer. And we see that across other trials. We've got some long running trials looking at soil amendments at Morley, so in Norfolk. One of those, we tried really pushing the system. So we started on a piece of land that hadn't received any organic amendments for a while. And we put 4 doses of green waste compost. Green waste compost is just compost that is basically from garden waste and bracken and tree root clippings that we send off in our brown bins and goes it's decomposed a little bit, and then farmers apply it to the soil. So we applied that in 4 years between 2008 and 2011, and we saw a relatively big increase in organic matter, again about 0.8%, I think it was. Don't quote me on that. I can't remember without the figures in my head, but we saw the increase in organic matter. And then in the plots that we grow winter wheat on, so just a wheat crop for every year over the last 9 years, we've seen on average a 4% increase in yield in those plots that have received the compost, just from having a more structure. There's not so much nutrients in there. The nutrient balance, like Sax-Mundham, should be enough to supply the crop, both nitrogen, P and K. But what we believe is that by having an increased organic matter, improving the structure, the crops can better utilize those nutrients we're applying. And therefore, in theory, we might be able to apply less and the environmental benefits that comes from.
David, thank you very much. That's really interesting, actually. Some fantastic results there. Thank you. Thank you both very, very much indeed for your time, for your input this morning. It's been really, really useful, really interesting. I've learned an awful lot as well. Roger and David, thank you very much for sharing your thoughts with us on your innovation today. For anyone who'd like to learn more about these innovations and the approaches taken to crop nutrient management by ADAS and by NIAB, please visit the Innovation Hub pages of the Agri-TechE website.